All right, boys and girls, this is section 11.9, solving equations with radicals. It's due Wednesday morning by 8 a.m. Section 11.9, page 521, number 1 through 29 odd. Please make sure your homework is in on time. I cannot guarantee you will get credit if you are not submitting it. It is a lot of work to correct the homework. So please, by the time I get to it, it needs to be submitted. All right, so solving radical equations. This is the section, again, to be done on Tuesday, due Wednesday morning. Okay, here we go. So before we were dealing with, if I had something like x squared equals 9, I did the inverse operation by rooting both sides, using properties of equality and using inverse operations, and then we get the absolute value of x equals 3. And so to lose the absolute value, we get x equals plus or minus 3. Well, when I get the square root of x, then I'm going to do the same thing. I'm doing the inverse operation, but the inverse of rooting would be to square. And when I square, I do not take absolute value. Okay, so what happens is that little square and the radical, they kind of, they cancel each other out. And so what I would get is x is equal to 81. But since I'm squaring one side, I have to square the other, right? Remember, properties of equality. So x is equal to 81. So there's only one solution here. Okay? So when I get something like number 1, I get rad x equals 16. To get rid of the radical, I have to square both sides. And then I get x equals 256. Pause the recording and try the next one on your own. Now, let's check our work. Square both sides, we get y equals 49. When you have more than one thing inside, we're going to still square both sides. Now you'll notice the 2 and the radical eliminate each other, so I get 2x equals 64. I'm dividing both sides by 2, and I get 32. Now, I do expect you to show me properties of equality, right? On the next one, before we can eliminate the radical, we have to get the radical alone. So I'm going to add 1 to both sides. I end up with rad 5x equals 15. I'm going to square both sides, and we get 5x equals 225. Divide by 5, and we get 45. Remember, I want to see you showing me all your properties of equality. Dividing by 8, dividing by 8. All right? Pause it if you want to take more notes. All right, so if I get something like this, we have to isolate the radical. So when 2 is next to, that means multiplication. So I'm going to divide both sides. If you want to pause it and see if you do this one on your own first, you can check your work with me afterwards. So divide both sides by 2. Then I get rad x plus 3 equals 5. I'm going to square both sides. Now I have x plus 3 equals 25. Subtract the 3, and x is equal to 22. By substituting it in, the 22, you should end up with a equal equation. On the next one, this is a multi-step, so we undo our addition and subtraction first. We're doing the reverse. So I'm doing inverse operations, add 5 to both sides, divide both sides by 3. Now, I'm going to square both sides to get rid of the radical. And then we get 2x plus 4 equals 36. I'm subtracting 4. Divide both sides by 2, and I get x equals 16. Again, when you substitute that 16 in, it should work out. All right, so when we're stating the domain of x, now we're going to kind of mix it up. We have a radical. So the radical rule is you can't have a negative under there. So we have to say x is an element of the rules, and x cannot equal, it has to be greater than or equal to 0. It can equal 0. It can't be a negative. X is greater than or equal to 0. On number 2, again, it's a radical, so the rule is no negatives in there. So I take what's underneath and I set it greater than or equal to 0, and then x is greater than or equal to -5. On the next one, there is no domain rule, so it can be any real number. It's not a square root and it's not a fraction. So we would say x is an element of the reals, or any real number. Number 4, I'm going to take what's under the radical and set it greater than or equal to 0, because it can't be a number less than 0. That would be a negative. So I add 6, divide both sides by 2, and x is greater than or equal to 3. So x is an element of the reals, and x is greater than or equal to 3. Now this is different because it's asking for the domain, not the restrictions. Okay, so if I ask for domain, you do say it's an element of the reals, as in the real number system. All right, next one. This happens to be a fraction, and the rule for fraction domain is you can't have a 0 in the denominator. So we're going to say x is an element of the reals, but x cannot equal 0. Pause the recording and see if you can try the next 3 on your own. All right, let's check. So we're going to set that 7x greater than or equal to 0. I'm dividing both sides, and x is greater than or equal to 0. So x is an element of the reals, but x has to be greater than or equal to 0. Since the next one is a fraction, the overall denominator, not the x, the overall denominator cannot equal 0. So what would make that overall denominator equal 0? If x equaled 4. So x is an element of the reals, and x cannot equal 4, not greater than 4. It can be greater than, it can be less than, but it can't equal 4. Back in the radical, x can't equal a number less than 0, so we're going to say 8 plus x is greater than or equal to 0. And so x is an element of the reals, and x is greater than or equal to -8. Okay? Okay, a lot of times, 90% of the time when you're doing equations, especially with quadratics and radicals, you will have solutions that are extraneous. So you have to check every answer. A solution obtained by squaring both sides of an equation that does not satisfy the original equation is an extraneous equation, an extraneous solution. For instance, I'm going to subtract 9. And then I'm going to square both sides. And I get x is equal to 81. When I substitute that in, the square root of 81 is 9. And 9 plus 9 does not equal 0. So in this case, 81 is an extraneous solution. Perhaps you saw the problem in the middle, okay, which was right here. Look at my arrow. Right there, you can see where the equation went bad. No number times itself will equal a negative. So when you are solving radical equations, you have to check your answer. You have to substitute it in and make sure that it's not an extraneous solution. So pause the recording and you guys try this one on your own and check it. Now let's check our work. I'm going to square both sides. Then I'm subtracting the 2x. I'm noticing this looks like a trinomial, but I got to get it all to the same side, so I'm subtracting 2x, subtracting 3. Here we go. What multiplies to -3 and adds to -2? How about -3 and 1? So x minus 3 times x plus 1 equals 0. X minus 3 equals 0, x plus 1 equals 0, so x is equal to 3, and x is equal to -1. Okay, now I'm going to try my answers. 2 times -1 plus 3, does that equal -1? So I end up with -2 plus 3 equals -1. It's the square root of 1 is not equal to -1. So this doesn't work. Then we're doing 2 times 3 plus 3. Does that equal 3? right? This time I'm substituting for 3. Okay, so that becomes the square root of 6 plus 3. Is that equal to 3? The square root of 9 equals 9. That works. So 3 is your solution. Okay? Oops. All right. This is our last problem. If you need me to keep that up for a minute. Okay, last problem. Why don't you guys try it on your own? Now, check your work. I'm going to square both sides. I get an x squared. I'm subtracting x and subtracting 20. What multiplies to negative 20 and adds to negative 1 is a negative 5 and a 4. So x minus 5, x plus 4. Okay. X is equal to negative 4 and x is equal to 5. So I have to try both solutions. I end up with the square root of 16, so negative 4 doesn't work. And now I'm going to try 5. And that works. All right, so just making sure that you check your extraneous solutions. Please make sure this work is done by Wednesday at 8 a.m. Thank you. Have a great day. The next time we meet on Wednesday, we will be reviewing the quiz.